So welcome students. So in this series of lectures of geometry meant specifically for IOQM, we have gone through basic geometry followed by lines, triangles, quadrilaterals, then certain theorems related to them. Now we will be coming to the part of circles. Once we have gone through circles, you will say that a huge box of questions where length chasing and angle chasing specifically opens, and you will see that the primary difficulty that one encounters in dealing with problems of geometry is angle chasing. That will be more fascinating as we move on. Now I am sure all of you would have heard the term circle. At a fundamental level you would have understood what it means. So we are discussing a circle, it has a center, P is a point on the circumference of the circle. This distance Cp is always equal to radius of the circle. C is center of the circle. This is circumference of this circle. Circumference of the circle everybody knows is 2 pi r. Area bounded by this circle is again pi r square. Basic terms, I am absolutely sure you would all have gone through it. Now certain things related to circle, every point which is equidistant from the center will lie on the circle. Now some theorems related to circles. Okay, so the very important theorem of angle chasing involves this, that is angle subtended by the circle, by a chord at circumference is half the angle subtended at the center. I am sure you would all be knowing how to establish it. Okay. So how do we go about it? If these two sides are equal, they are all center of the circle. This is center of the circle, they are all radii. So if this is theta, this will be theta. If this is alpha, this will be alpha. So this angle is this angle is 2 theta plus 2 alpha. Okay, so this is what we were saying. Now you can say possibly that the diagram could have been like this. Let's suppose this is the center and say you are dealing with this point. Okay, when center lied inside the triangle PAB, then it was another possible figure could have been this. Okay, here also we are saying that the same thing. So as such, there will be no change, you will do the same thing. you will be doing the same thing if you are able to see. If this is theta and this is theta, okay, this is theta, this is theta, this would be pi minus 2 theta at the center. And if this is alpha, and this is alpha, sorry, okay, and if this is alpha, and this is alpha, okay, what is this angle? Pi minus 2 alpha. This angle was pi minus 2 theta. Okay. Now you can very easily see what this angle is. This angle is alpha minus theta. And what is this angle? This minus this is 2 times alpha minus theta. So whatever may be the situation, okay, I just wanted to make sure that everybody recalls this. As I have been continuously saying, that if you read any theorem, please try to prove it. That is an essential, because you have learned. See what I have done. See, one of the triangles here was PCB. So you are doing the same thing. One of the triangle is PCA, other triangle is PCB. I know what the mistake I was doing it was I was doing considering the triangle ABC. So in either cases we are effectively doing the same thing. Okay. Now moving ahead, this is a theorem that we very frequently use. As a consequence, we say angle subtended by circumference, sorry, by diameter, sorry, very sorry, is right angle. Okay. So please remember this, angle in the semicircle is right angle, angle in the semicircle is right angle, that is what is also said. And therefore, if somebody says that AB subtends an obtuse angle, so we can say it will lie inside. If it subtends an acute angle, we will say it lies outside. So this plays a very important role in geometry. Suppose I am saying that P is a point moving such that angle AB and fixed points, P is a point such that angle APB is always obtuse. So we can say that it will lie inside the circle with AB as diameter. It will be of great help in solving a lot of problems. The moment we say that the angle subtended by a fixed chord is 90 degree, we are able to assume that there is a circle with AB as diameter can be drawn. On occasions it might be useful. Post that things are of great importance, especially while chasing angles. We will come to problems as we move on. Okay. Sorry. Now, suppose somebody wants to do a problem on this, okay. let me say the problem could be suppose somebody says in an acute angle triangle ABC H is the orthocenter. Now somebody asks you to show that, let me draw with a different color. If this angle is theta, so this angle is theta. If angle BAC is 70 degree, find theta. Okay, find angle AD. Again, see two right angles. What are they indicating? What they are indicating is, see, this is the right angle, this is the right angle. So what we say by observation is that this two is an altitude. Circle with CH as diameter. Circle with CH as diameter passes through this is the utility of angle in semicircle is right angle. Okay, circle with CH as diameter will pass through E and H. Now, just by the theorem we have gone through this, what will be the corollary of this? Angle in same segment are equal. You can very safely say, if I draw this diagram, this angle 2 will be theta plus alpha. If I draw this, for every one of these points, the angle at the center is 2 theta plus 2 alpha. Okay, so what we see is that angle in same segment are equal, even when the diagram is like this. All these angles are going to be equal. Fine. So if this angle is theta, this angle is also theta. This is angle A, this is 90. So theta is 90 minus. So what is theta? Theta is 70 degree, 20 degree, very sorry. This is how I am saying that the angle chasing plays a very important part. Even when lengths are involved, once we get angles and one of the sides, other things just follow. So just I was giving you an example where angle in same segment, angle in semicircle is 90 degree. These play very important role in solving our problems. As a corollary or as a independent theorem, this is arguably the most versatile of them all. Whenever you are dealing with angles, please keep this in mind. Okay. Now you can here see that if, sorry, it will be too clumsy. This is theta, this is 2 theta, and if this is alpha, this is 2 alpha. This I will leave to you as an exercise. Okay, just look at this, that just as I hope you would have learned something from the first proof. What we are saying is that if this is alpha, this is 2 alpha, meaning thereby that two theta plus 2 alpha is 2 pi. That is the sum of opposite angles of a cyclic quadrilateral is pi. This, just as I told you how to proceed, I expect that you start in the similar manner. Okay, this is the chord. What did we do here? A, B, P, C. There are 4 points. Okay, so A, B, P, C. So I hope you will be able to deal with it, hai na? First think of PCA. Okay, if you so this is again, this is theta, this is pi minus 2 theta. So this would be 2 theta plus 2 theta. Okay, and this whole angle you can say. Now this is a cyclic quadrilateral, whose cyclic quadrilateral means vertices lie on a circle. Fine. Now moving ahead, please think that this is the most widely used theorem or corollary, that is, angle in same segment are equal, angle at the center is twice the angle at the circumference. You will see whether you are dealing with problems IOQM, RMO, INMO, almost everywhere you would come across a situation where this is to be used. Be absolutely sure, whenever in doubt, at least this thing can always be utilized. Now regarding chords, what we can say is that equal chords are equidistant from center. Further, perpendicular from center bisects the chord. Equal chords subtend equal angle at the circumference. Of all the chords that pass through a point inside the circle, shortest chord is the chord whose midpoint is the given point. Length of a chord nearer the chord is to the center, the longer it is. And you can see that the smallest chord, theoretically speaking, the tangent would be having length 0. Okay. Now, how do we justify all of them? Equal chords, you can say, suppose you are in a circle, you are taking two chords of equal length. These two are equal, others are automatically equal. So, these two are congruent triangles. So, if they are congruent, their altitudes from center are going to be of equal length. Now, insofar as perpendicular from center bisects the chord, suppose you draw an altitude. So, by RHS, these two triangles are congruent. So, it is bisecting. Equal chords subtend equal angle at the circumference. You can see that these two angles are equal. So, angle subtended by this chord at the circumference and this chord at the circumference, they are going to be half of this angle. So, they are obviously equal. Now, of all the chords that pass through a point inside the circle, shortest chord is the chord whose midpoint is the given point. So, how do you get to it? Say, suppose this is the chord whose midpoint is, suppose this is the given point. Now, there are infinite chords that you can draw passing through this point. Now, what you can see that if you draw a perpendicular from center, if you draw a perpendicular from center, CM is hypotenuse of these triangles. So, all other chords are nearer to the center. The nearer the chord is, the lengthier it is. Okay. So, this is the chord which is going to be farthest from the center. the farther it is from the center, the shorter it is. So, that is what we are saying this is the shortest chord of all the chords that pass through a point inside the circle. The shortest chord is the chord whose midpoint is the given point. So, these are few facts that we came across, something that we use very often in dealing with problems. There are a lot of theorems as we move on that we go through, but at the initial stages these things might suffice in dealing with various problems of circles that we come across. Okay, there are definitely a lot of other theorems that we go through. We will go through as we solve different problems. Okay. Angle in semicircle is right angle, angle in same segment are equal, they play a very significant part in dealing with problems. That is why earlier also I told you that angle chasing substantially increases once we get involved in problems of circles. Fine. Now moving ahead, let me solve one or two problems. Suppose you are given a circle, a very simple problem is if radius of the circle is 13 and length of the chord is 24, how far the chord is from the center? So, very easy, you can almost understand what we are going to do, isn't it? What we are going to do? Say perpendicular from center will bisect the chord. This is a right angle triangle, this is 24, this is 12, this is 12. So, its distance from center is 5 units. So, it is a distance of 5 units from the center. Okay. Now, suppose I ask you a problem like this. Okay. Suppose this is a circle and this is center, this is A, this is B. This is 1:3. Now, if somebody is asking you to find, given that radius, suppose I give you radius as say 8 and this distance as 4, what is length of this chord? I am sure what you are going to do, we are being asked to find length of this chord. Okay. This is ratio 1:3. So, what are you going to do? Stewart's theorem can be used. I hope you remember it, that if this is lambda, this is 3 lambda. Okay. So, this is your m, this is your n. A is so what it is? It is MAN. Will the calculation be too tedious? MAN plus DA D C and C. plus BMB. So, what is CNC? This BMB, so 64 lambda BMB plus 64 into 3 lambda. So, 12 lambda cube plus 64 lambda is equal to 64 lambda plus 64 into 3. This gets cancelled, and what do you get is 60. So, lambda square is 60. So, lambda is 4. If lambda is 4, so this is 4 and this is 12. The length of the chord turns out to be 16. How is this possible? There is some error in the way we have solved it. So, what is the error that we have done? M A N plus D A D B M B B M B C N C. 64 lambda. Oh, 16 for the 64. That's fine. So, how could this be 16? Okay. If this is 16, so be it. You know? If this is the chord. So, what is the situation? The situation is like this. This is 8 and this is 8. Fine, everything is fine. You know? I just randomly took the data. It turned out to be the diameter. Okay. No issues. You know? If that is the situation. Other way we could have done is that suppose we are not able to recall Stewart's theorem, then ideally we would have done it like this. This is how I would have done it, because so this is 4. So, we drop a perpendicular. Okay. So, if this is lambda, total length was 4 lambda. This is also lambda and this is 2 lambda. This is 8. So, you could have written the altitude as this altitude in this right angle triangle. Suppose this is C M P. So, we by Pythagoras theorem we would say Cm square is Cp square minus Pm square, and (16) minus lambda square is, so 3 lambda square is 48. Lambda is 4. This is also one way we could have proceeded. So, just the fact that angle in same that chord perpendicular from center bisects the chord, you can use that. The perpendicular bisector of the chord passes through the center. So, these are just one and the same thing, converse of it. Okay. So, what you can see is that initially the problems that we are doing, these problems are primarily of length chasing, but the properties of circle that we have gone through has helped us in solving it. We could have used this also, I am not denying it, but I would have preferred it being done this way. again it is not something, it is an individual's priority, what priorities he had set up. Okay. Now, some more problems regarding the theorems that we have gone through. So, one very simple thing that as a corollary is that even if I treat it as a problem, you can say that suppose you have two chords, okay. So, PA into PB is PC into PD. Two chords AB and CD meet at point P, the rectangle contained by PA and PB. Okay, if two chords meet at P, the rectangles, this is how it is written, the rectangles contained by PA and PB is equal to the rectangle contained by PC and PD. So, you can very easily see, okay. Angle in same segment are equal, okay. Suppose you say this angle is alpha, then this 2 is alpha, this is beta, this 2 is beta, these two are definitely equal. So, these two triangles are similar. The rest follows, I think. Opposite to alpha PA, opposite to alpha PC, opposite to beta PD, opposite to beta PB. PA into PB is PC into PD. Now, this point could very well have been outside. Okay, in that case, what do we do? See, the process everywhere is same. If this is alpha, okay, this angle is alpha. We just went through this. If this is alpha, this is pi minus alpha. Okay, just now if this is theta, this is alpha, their sum is pi. So, if one is theta, the other is pi minus theta. Okay. Similarly, if this is beta, this is beta. Again, triangles PAB is similar to PCB, PAD, sorry, is similar to PCB. So, you can see opposite alpha PB, PAD, opposite alpha PD upon PB. Okay. PA opposite to PC, PA into PB is PC into PD. And what is PA into PB is PC into PB. So, what does this tell you? That if you draw from external points different chords, different lines which meet the circle at 2 points, the product of the two segments, they are always going to be equal. Suppose this is EF. So, PA into PB is PC into PD is P into PF. Once we come to tangents, we discuss other things also. Okay, what is this length equal to? You can understand as these 2 points coincide, what you get is tangent. So, PT into PT. There would be other proofs too, but this time for the sake of argument I am saying that if these 2 points coincide, PA into PB, PC into PD, P into PF is PT into PT. That is PT square, square of length of the tangent from an external point. Okay. Now, regarding tangents, let us first in this class understand all the major properties that we encounter. Problem solving is something that we learn slowly. In my belief, that would be better, so that we are not hindered by problems, that this has not been gone through, this has not been gone through. So, insofar as tangents is concerned, it is a line which meets the circle at only one point. Okay. So, you can say this angle is 90 degree because this point itself now becomes midpoint of the chord of length 0. Okay. So, perpendicular from center rather than saying perpendicular, what do you say? Radius. Radius at point of tangency, tangency is perpendicular to tangent. Okay. This is also a very useful thing. Further, this is said angle in alternate segments are equal. Angle in alternate segments are equal. Fine. See, if you wish to establish it, how do we establish it? You can see this is 90 minus theta, this is 90 minus theta, so this is 2 theta, so this will be theta. Okay. So, this is 90 minus theta, that would be theta. This is center, so angle at the circumference is half the angle at the center. Okay. Just I told you just some moments ago that this is PA into PB is PT square, if you recall. Okay. So, I would ask all of you to prove this. Okay. You can draw, so this is T. PTA, PTB. So, suppose this angle is theta. Which angle is now going to be theta? Angle in alternate, this is theta. This angle is definitely common. So, therefore, these two angles are equal. So, these two triangles PTA, PTA and PBT are similar. PTA, है ना? Now, opposite to theta, in PT, opposite to theta, you have PA. In PBT, opposite to theta, you have PT. Okay? Now, opposite to this, in PTA, you have PT, and opposite to this, you have PB. So, PA into PB is PT square. A very, very useful thing. You will see that it is very often utilized in dealing with problems. So, today a lot of time I have deliberately spent just on deducing the basic theorems that we are going to continuously use. I was advised by Prashant sir that we should teach the basic theorems too. So, I am definitely sticking to it. So that all of you get the gist. I am saying that we could have solved a problem where this was to be utilized. We will do so as we move on, but any theorem, suppose I have not told you the proof, please go to your home as and when you get time, please try to prove it. Otherwise, you will see that ultimately they will be of no use. You can see these two angles being equal, alternate segments being equal. Okay, angles in the alternate segment being equal have led us to this. There are different ways to come to this conclusion, but we have utilized this at this juncture. Further, say you can draw two tangents from an external point. Okay. This is PC. So, you can very easily now see that PA and PB are equal. These two triangles are congruent by RHS. So, PA and PB are equal in length. Fine. Now, if we have gone through sequence and progression and stuff like that, we can say that C is midpoint of say QR. QR. So, PC is arithmetic mean of PQ and PR, and PA Square is PQ in PR, is geometric mean of PQ and PR. In fact, the term geometric mean comes from here only, that if you have a circle and what is this length? Perpendicular, if you draw perpendicular, this is the diameter say. What is this length? X. So, the term of geometric mean comes from this only, that you simply extend it and you say perpendicular from diameter bisects the chord. So, this is also X. So, X square P C into P D is P A into P B. So, what is X? Root P A into P B. So, the term geometric mean, if geometric mean of A and B is root A B, is in effect named because in a geometrical situation this is what appears. That is why it is called geometric mean. You can say this is 90 degree, this is 90 degree. So, what can we say? If you recall just few minutes or say 20-25 minutes ago, we went through this circle with CP as diameter, circle with CP as diameter, passes through A and B. In fact, this circle is circumcircle of triangle P. Circumcenter would be midpoint of PC. Okay. Now, just based on this fact, if somebody asks you, see a question like this, you consider a circle of radius r, say 2r. Now, draw another circle of radius r. From B, draw tangents. Okay. What we are saying is that this circle has radius r, this circle has radius 2r. From B, you draw two circles touching at D and E. Fine. So, if O is circumcenter of triangle BDE, determine CO upon C, let us say CECA, that will be one and the same thing. Now, you can very easily see what is the length of these tangents. If this is r, BC is 2r. This is r root 3. This is also r root 3. Fine. So, can we find the angles also? This is r root 3, this is r root 3. I hope you are aware of bit of trigonometry, or let me avoid it. Let me avoid using any trigonometry. Let me deal with it in a different manner. So I have to find this length, okay. Suppose this length is x. So I would say area of this triangle is half r into r root 3. Area of this triangle is also half base into height. So x is r root 3 by 2. So this is all in all r root 3. So this triangle now becomes equilateral. Now we can safely say they are all 60 degrees. Now just some moments ago we said circumcenter of PC, circumcenter of PAB is midpoint of PC. So circumcenter of this triangle is midpoint of BC, which is nothing but A. Since this is an equilateral triangle, A will coincide with O. So your answer, what is the answer? CO by C is simply 1. Got it? So these facts do help us in dealing with problems. This is a good problem. I knew the solution, so I directly took it the way it should be. But determining that this is an equilateral triangle is an ask. I deliberately avoided trigonometry for the purpose that, say, if we are able to do it geometrically, that will be better. In this, what we used is length of the tangent. So length of the tangent from an external point, I hope you are able to see. We said, okay, so length of this tangent PT, whenever we have to find length of the tangent, what do we do? This is 90 degree. Okay, so what is length of the tangent? Root, we say it is root of d square minus r square. More on common tangents to two circles and other things. Okay, today we didn't do much problems. In the next class, we will initiate with problems and then further we will go to various problems that we encounter. Now will come the fascinating part of geometry, which will include quadrilaterals, cyclic quadrilaterals, triangles, similar triangles, circles. So now you see that how enriching the whole content is going to be. In the initial 5-6 lectures, we were trying to build it. Now will come the time where we will be able to apply it, to use it in various situations, how fresh situations, how good situations come across. Okay. So I hope you would have learned from it. Thank you very much.